Okay, let's get ready to start the class. Before we start, let's share some good news. Today is the 26th, right? Yesterday, the 25th, one of our students in Singapore passed the CCIE Lab exam again. Since April 9th, our CCIE Lab has been stable since a student resolved the design debate issue. Right, after that debate, he passed, and our CCIE Lab has remained stable for so long. Continuously passing, right? We basically post updates every 2 or 3 days, right? This student is even more impressive. Tarzan, we call him Tarzan, because he is a Singaporean, a foreigner, and also a female PhD. Very impressive. And their communication with us is all in English. Basically, also in Singapore. Again, right? Passed the exam again. Because previously the lab was unresolved, right? So at that time in Singapore, there were many exam slots in China, right? So lately, these exam slots, the students in these positions have been continuously passing the exams. And we have noticed that some institutions are still saying, hey, we are still getting the old questions, but actually, they are new questions, right? Okay, if students feel the learning is good, then they can listen together during our NP and IE stages. Then they can quickly get into exam preparation. Currently, it is very stable. Let's review the knowledge points we talked about last class. Last class, we discussed mainly about the computation of EIG RP's metric. This formula, remember it. Then the direction of route propagation. Hey, our incoming direction has such a minimum bandwidth, and also our sum of delays are the only variables in these two formulas. Then using 10 to the power of 7 to handle our route entry propagation direction, the incoming direction's minimum bandwidth, taking the minimum value plus the sum of delays from the source in the entire route entry propagation direction, finally divided by 10 times 256. This is our entire EIG RP's metric value computation formula. Then we talked about EIG RP's dual algorithm, which elects route entries. Firstly, electing a successor route, which means our FD value, our router's metric value, to the destination being the smallest route entry, submitted as the optimal route to the routing table. Then there's such a thing as a feasible successor route, which is also stored in our EIG RP database table, serving as a backup path for our optimal route, called the suboptimal route. Its condition is quite interesting, which is that our optimal route's FD value, our suboptimal route's AD value, the suboptimal route's next hop router, going towards the destination segment's metric value, as long as it's less than our optimal route's FD value, then it can become our feasible successor suboptimal route. Once our successor route fails, we will immediately submit it to the routing table, replacing our original successor route. Then we talked about how we change EIG RP's metric value. I mentioned in the formula we can adjust by changing the variables in the formula, our sum of delays and minimum bandwidth. We can adjust the metric value of the route entry. But in such cases, if the values are very large, then adjusting them can be very tiresome. Then we can use specific tools, offset lists, which can be used in distance vector routing protocols, to increase the metric value, but note, it cannot decrease. Then, on one direction on one interface. We can only use one directional control list. We cannot call multiple lists. This is what we talked about last class. Our cat wants to do what? CCIE cat. Our cat wants to attend the class. So today we will talk about, firstly, about what we mentioned last class. We will discuss a summary concept I'll show you. Our cat is attending the class. It's attending the class right here. Can you see it clearly? That blackish gray one, a British short hair blue. Not an American short hair, but a British short hair. It also wants to attend the class. This cat is at least at the NP level. At least it has the NP level. It has attended several NP classes. Let's continue. About the concept of summarization, students, today we first talk about EIG RP summarization. Please take notes. EIG RP summarization. This cat is also a female, right? It seems to have attended 3 IE sessions and 3 NP sessions. It doesn't really attend IE classes. It doesn't really listen to IE classes. NP are Huawei NP classes, not Huawei's IP classes, and our CCNP courses. It prefers to listen to. It doesn't listen to NA classes, just listens to NP, don't know why. Then EIG RP summarization. First of all, students in the early days, we considered as far as our devices, routers, then if we announce route entries, all of them would be detailed routes. Suppose at this moment there's a diagram, R2 and R1 are running. EIG RP Distance Vector Dynamic Routing Protocol. So on the R2 side, we created 6 loopback interfaces corresponding to these IP addresses from 2.2.2.1 with a 32-bit mask, and they all use 32-bit masks. So 6 loopback interface addresses were created. Then we announced these 6 interface addresses to run in EIG RP. Then the interface corresponds to direct route, for example, 2.2, 2.1-3, 2.2, 2.2-3, 2-3-4, then there will be 6 route entries, all announced to our EIG RP neighbors. Announced over, so as for R1, we could learn these 6 from 2.2, 2.1-3, 2.2, 2.2-3, 2.2, 2.3-3, 2, we would talk about 6 detailed route entries, right? Students. This is the distance actually, dynamic routing protocol operation method. So now for R1 to say, then we need to access these 6 route entries, all coming from you. Our next hops all come from R2. Next hops are all it. So actually we access these network IP addresses, all have to go through R2. But the same next hop address, this bunch are all the same, next hops are all R2. We have to store all 6 entries. Then clearly our next hop is the same. All are the route entries it told us. Can we not consolidate these route entries? Anyway, their next hops are the same. Anyway, they are all doing what actually can be consolidated into the same website, such a route entry. We have to receive these 6 detailed routes, which occupy our routing table, right, students? Because actually, when the router forwards, how does it do when the router forwards? We talked about access the destination address, find the routing table entry, how to go for the longest match, go for recursive querying, find to the destination address, the most accurate routing entry, then find the next hop address, or out interface throw out. So you see, if we need to access a destination address, 2.2.2.4, R1 needs to access the destination address. I need to go inside the routing table, longest match recursive querying, among the 6, find the unique such a routing entry, then the next one throw to R2. The more routing entries, the more time it takes to find a route matching the destination address, which also uses up device resources. So, having many routing entries stored in the routing table also occupies the routing table's cache. Thus, we've considered a solution whether we can consolidate these detailed routing entries that have the same next hop address and can be consolidated. Can we summarize them to reduce the number of entries in the routing table and still achieve normal forwarding? This is the concept of summarization. Regarding summarization, in the early days, each dynamic routing protocol had 2 types of summarization. The first type is automatically initiated by the routing protocol, called auto-summarization. Auto-summarization is quite simple in concept. It's defined as follows. When a router is about to advertise detailed routes, it checks the detailed routes and whether they match the primary class of the outgoing interface. If they differ, they are advertised. If they match, the detailed routes are summarized into a primary class route and advertised. If a detailed route's primary class matches that of the outgoing interface, it is advertised as a detailed route. So if the primary classes of the detailed routes and the outgoing interface match, they are advertised as such. If they are the same, the detailed routes are advertised. This simplifies the routing table. What does it mean, students? In the early days, we thought about allowing our routers to automatically summarize routes that have similar characteristics. These summarizable routes to automatically do what? To summarize them, thus reducing routing table entries without affecting forwarding. So what do we say? If I want to advertise a detailed route, suppose between us is the 1.2.1.2.0/24 network, written here. Our intermediary is the 1.2.1.2.0/24 network. So R2 is 1.2.1.2.12, R1 is 1.2.1.2.12.1, so-called auto-summarization. When R2 wants to advertise a detailed route, For example, I want to advertise a 2.2, 2.1/32 detailed route. When advertising, then I will check if my detailed route's primary class matches the outgoing interface's primary class. What is a primary class? Back then, according to the IPv4 address classification, we had Class A, B, C. Class A address starts with 126. Then it has the first 8 bits as network bits. Class B, 128, 191. Class C addresses 192, 223, corresponding to the first 16 and 24 network bits respectively. So when we thought about summarization, all IPv4 addresses could be classified in a classful manner. We felt this characteristic was quite distinctive, so your 2.2.2.1, is it the primary class, right? Forget the mask, I'm not looking at the mask anymore. Your primary class is an IPv4 address, starting with 2, okay? Then you are a Class A address, with the first 8 bits as network bits, 2.2.2.1. The first 8 bits are network bits. Network bits differentiate the network segment. The rest are host bits all zeros. 2.0, 0.0/8, our 2.2.2.1, our IPv4 address belongs to 2.0. 0.0/8, with the first 8 bits as network bits. We belong to this network segment. This is our IPv4 address's primary class. We need to advertise this detailed route's primary class is 2, 0.0-8, so R2's outgoing interface's primary class is the IP address 12.12.12.2, so we also have a Class A address, with the first 8 bits as network bits. All host bits become 0. Our primary class is 12.0, 0.0/8, a single primary class. The primary class of the routes we advertise is 2, 0.0. What you advertise, the primary class of the outgoing interface, where route entries are sent, is 12.0.0.0. The two primary classes do not match, right? So our router automatically does what? It summarizes your detailed routes, converting them into primary class routes for advertisement. I will not advertise the detailed route 2.2, 2.1/32, but will advertise the primary class route 2.0, 0.0/8, not detailing, just advertising the primary class. In this way, students, if we perform auto-summarization, think about it. These 6 routing entries, how one cancellation can pull all these back. This cancellation is too powerful. So, if the detailed routes we advertise are all created by us above, these loopback map routes, then the primary class of 2.2.2.1 doesn't match the outgoing interface's primary class. Advertise 2.0, 0.0/8, advertise 2.2.2.2 as 2, 0.0/8, advertise 2.2.2.3 as a summarized route, 2, 0.0/8, 2.2.2.4, 2, 0.0/8, 2, 2.5, 2, 0.0/8, 2.2.2.6. All these detailed routes will do what? Because of auto-summarization and mismatch with the outgoing interface's primary class, become primary class routes. Turn all these 6 detailed routes into what? Don't announce details anymore. We advertise all as 2, 0.0-8, for R2. With so many detailed routes, I only need to announce one route out. That's enough. Just announce one. So R1, we can only receive 1, 2, 0.0-8 summarized route. Unlike before, I needed to receive 6 detailed routes. Do you think there's a problem with access? Our R1 receives routes from R2. The next hop is still R2. So if I want to access 2.2.2.1, according to the routing table I set off, this primary class includes our destination address. Does the subnet contain the destination address? Can be forwarded according to the routing table and given to R2, 2.2.2.2, can also be forwarded according to the summarized route. Also to R2, you find that after auto-summarization it seems not to affect, and also the routes are reduced. But students, auto-summarization, we now find it's not much used. If students are working, they also find auto-summarization not useful. Why? We can see this phenomenon in experiments. So R1 here, we have a loopback address. Then 10.10, 1.1/24 comma, it generates a direct route, October 1st 10. 0.24 detailed route. R32, then we have a October 3rd 10. 3/24 interface address, generating a direct route, October 3rd 10. 0.24 detailed route. So suppose I now on R1 turn on auto-summarization. Of course, if you use the first version, in our most current or newer versions of our Cisco's image operating system, such as if our router is version 15.8 of iOS. If you encounter some older devices such as 12.4, 12.3, then those EIG RP distance using routers are by default automatically enabled. Auto-summarization is by default on. Automatically starts auto-summarization. Then we need to turn it off. Because auto-summarization is very superfluous, we will immediately explain why it's superfluous. Firstly, on the R1 side, we go to router EIG RP 90, start auto-summarization. Of course, if you are using the first version. Then by default it's enabled. But in our current version, by default it automatically disables it. So you don't need to enable it. Impressive, right? Today we had 3 CCIE exams. Guess why WeChat was buzzing? Why was WeChat buzzing? Because today, all 3 CCIEs passed. A student surnamed Wang, one of them, on April 26th in Beijing, passed today. The second one, what's the surname? It's Zhang. Student Zhang, a student surnamed Zhang, a student surnamed Zhang, also in Beijing, passed, right? On April 26th. And another one, the third one, Student Ann. Why was WeChat so active? Because they passed. Look, took the exam in Japan, in Tokyo, on April 26th. Today, 3 CCIE students, awesome. And the latest news, indeed, there was a debate last night. But we coached the students. We actually gave them extra coaching. Today, they all passed. Awesome, right? Students, we can really brag about this now. Look what else we could talk about. Some institutions are still saying that we were all tested on old questions. That Wolf isn't very useful, but we were tested on new questions. Indeed, everything matched last night, and there's more news today. Brag a bit, we'll talk about it later. Let's take a breather. I'm also a bit excited, because today actually there was a bit of panic. Actually today, our Wolf, you see today actually felt more oppressive, didn't chat much. When we came to work today, later everyone felt not very sociable, just because of the nerves. Why? Because the students who finished the exam today said, "Teacher, it seems like the questions changed a bit, our hearts went cold, but the result was good, awesome. The coaching last night, our coaching, the emergency training was no problem. Congratulations. Cisco is better than Huawei." Why? With Huawei, after you finish the exam, you have to wait a week. About a week and a half. You finish and don't know the situation. You have to agonize for a week and a half, waiting for the result. And your mood fluctuates during this time. Waiting for the result is really stressful. But with Cisco, once you finish the exam, the result comes out immediately, right away. Where were we? We were enabling automatic summarization on R1. So if it's a newer version of Cisco's EIG RP, automatic summarization is off by default. Now let's turn it on. Of course, this automatic summarization is certainly not very suitable. Otherwise, why would it be turned off? For example, now that R1 has it enabled, let's look at what entries it adds in the EIG RP database. Our direct route 10.10.1.0, once placed in the database, what do we automatically generate? A summary route for 10, 0.0-8, comma. Look, is that a major class route? Let's look at our routing table. Look, R2, we can learn a route. Seeing one from R1 being advertised to me, a major class route of 10.0.0.8. What route disappears? R2 can't see the detailed route of 10.10.1.0, 24 anymore. What do we see? Because R1 has enabled automatic summarization. When I announce route entries, I summarize detailed routes into a major class route to announce directly. A major class route of 10.0, 0.0-8, comma, right, teacher. So after summarization of detailed routes, doesn't it look particularly good? If there are many loopbacks on R1, as in the initial example, then they can all be summarized. But this is also a drawback. Students, First of all, the first drawback, automatic summarization has a very broad scope. The scope regarding its range is very large. How large is it? So, for example, on R1, what we do, then we create a loopback, IP address 110.255.255.254 with a 24-bit mask. I declare it into EIG RP 10.255.255.254 with precise declaration 0.0. Can EIG RP store it? Does the database have entries? So what route is announced from it? Look, on R2's side, what we see is still what? Can't see the detailed route, only a summary route, because our primary class, our automatic summarization, has a very broad scope. What does it summarize? It automatically summarizes the primary class, students. Think about Class A addresses. It summarizes all as 10, 0.8. For example, if I have some detailed routes that I don't want to be summarized, like if I want to set up a primary backup, it all gets summarized. You can't manually control it. Students, it's completely automatic summarization. You can't manually interfere. This is a problem. Its scope is very large. The impact is significant. Furthermore, if we summarize in multiple places, there will be problems. What problems, students? So if I also turn on automatic summarization on R3, router Agrippa 90, I also turn on automatic summarization, okay. After we also turn on automatic summarization on R3, I'm originally announcing the detailed route of 10.10.3.0. What happens after automatic summarization? The primary class summarizes to 10.0.0.08. Think about it, R2 here's 10. 0.0-8 from the left, 10. 0.0-8 from the right. Which way do I go? Isn't it possible that you see it becomes equal cost load balancing? You could go via R3 or R2. Now, if I want to access 10.10.3.3, and I'm matching this detailed route, I have two next hops. Do I go via R1 or R2? What do you look at, right? We'll talk about equal cost load distribution later today. I'll give you a spoiler. If I now go to access 10.10.3.3, how would R2 route it? Show IP Ceph 10.0.0.0.0. So now if I go to access 10.10.3.3, I go through whom? 172.16.1.2.1, comma, I go via R1. Like now I match 10.10.3.3. I go through you. Damn. He now takes a detour. Because at this time, how do you say? He now, although connected, but first goes via R1. How do I brag about it? You see, he first goes this way, students. Do you see? First, who does he go through? Goes via R1. This definitely doesn't work. You can't do this after automatic summarization. It very likely puts the intermediate router in a difficult position. What does the left give me? 2.8 routes, 2.8 routes on the right. If I access the right, he goes left. Isn't this confusing? You can't do this, students, right? You can't do this. So, automatic summarization so easily causes what? It easily results in suboptimal or directly unconnected routes. Very nasty, students. It's completely done by the router automatically. You can't manually control it. So